The wave function collapse algorithm is a promising procedural generation algorithm that can generate interesting results from a single sample. Wave function collapse has been successfully used in games such as Townscape of Bad North and Caves of Quid. However, it has some limitations. In all these games, the size of the world is limited due to the performance of the algorithm and the lack of efficient backtracking. When a contradiction is found in wave function collapse, most implementations simply restart generation, while a few have basic backtracking. This makes generating large scenes with complex tilesets slow or even impossible. We extended the wave function collapse algorithm to fix both of these issues. We came up with a novel chunking algorithm that minimizes contradictions. First, the world is split into chunks that can be generated independently. The chunks are then generated spreading out from where we started. Finally, we apply some chunk stitching rules to make sure everything fits together. By processing everything in chunks and multi-threading the chunk generation, we get a massive speed up. Here you can see a 10 times improvement over wave function collapse without chunks. The greater the generation size, the greater the speed up. To fix the contradictions, we came up with an optimized backtracking algorithm. Every time we collapse a node, we store what decision was made. When a contradiction occurs, we use the stored decisions to roll back to a previous state. By only storing individual decisions rather than the full wave function state, and using heuristics to decide how far to backtrack, we can have fast, efficient backtracking. Here you can see the performance of different heuristics and their corresponding decision graphs. The naive method tries many branches, having to do heaps of extra work. By using heuristics, we can efficiently explore the possible choices and only require 2 backtracks. The speed improvements for our extensions will allow users to explore new use cases like real-time generation, larger worlds, and 3D environments.